These are the Lesson 13 3 notes on radian measures. Today what we're going to do is we're going to convert between degrees and radians. We're going to locate radian measurements on the unit circle, and we're also going to calculate something called the length of arc. Now you may recall that in a circle there are 360 degrees in a circle. There's another measurement that you can use to measure the distance around a circle, and that's using a measurement in radians. Now what is a radian? You probably know what a radius is. A radius is the distance from the center to the outside of the circle. Now if you were to take the same length and bend it so it's an arc around the circle, what you'll notice is that you can fit 1, 2, and almost 3. You need a little bit more than 3 to get halfway around the circle. And if you keep going, 4, 5, 6, you can fit basically 6 and a little bit more. In fact, this is about 0.28, 28% of a radian or radius right here. So you could fit just over 6. Specifically, if you want to know exactly how many radians it can fit, it's based on this value that's called the circumference, which is the distance around a circle. You may recall that the formula for the circumference is equal to 2 pi r. That's the distance around the circle. There are 2 pi. Now 2 pi is 2 times 3.14, about 6.28 radians around a circle. It's based on our circumference formula. So the number of radians, or radiuses in a circle, is equal to 2 pi. Take the distance of the radius. There are 2 pi, or 6.28 times this value around a circle. So that's what we say the number of radians in a circle is. It's 2 pi. If you're converting between degrees and radians, therefore, there are a couple of conversion factors you can use. If you're going from degrees to radians, the conversion factor you want to do is multiply by 2 pi over 360. This is a fraction that can be also reduced because the numerator and denominator are both divisible by 2. You can say multiply by pi over 180. That's your conversion factor going from degrees to radians. On the other hand, if you're converting from radians to degrees, we're just going to flip this fraction and we'll end up multiplying by the reciprocal, which would be 180 over pi. So for example, if you're at 180 degrees, you want to know halfway around the circle, how many radians is that? What you can do is you can start with 180 degrees. We're going to multiply by our conversion factor, which is pi over 180. If you do this correctly, what you should find is that the degrees should cancel, and what you're left with is this value, which is this pi radians. So halfway around the circle, you need 3.14 of these radiuses, or pi radians, to get that distance. So 180 degrees is equal to pi radians. What do you do if you have a fraction that's a little bit tougher to work with? Which will be the case here. If you have 210 degrees, we're still going to use our same conversion factor, pi over 180. This time, again, the degrees will cancel, but the numbers don't necessarily cancel. What you get is 210 times pi over 180. Now if you recognize you can divide the top and bottom by 10, that would cancel out the zeros. You can actually divide a 3 out as well. Isn't that the same as dividing out a 30? Yeah, it is. Basically, if you divide out this 30 from the top and bottom, you'll be left with 7 pi over 6. And that's the reduced form for radians that I'm looking for. What I'd like you to do is pause the video and see if you can convert negative 45 degrees to radians. So to convert, what we do is we take negative 45 degrees and multiply by pi over 180. That gives you the fraction negative 45 pi over 180. Now, it's obvious that you can divide both the top and bottom by 5. If you did that, 45 divided by 5 is 9, and 180 divided by 5 is also equal to 36. 9 over 36 is the same as the fraction 1 over 4. You could have also gotten that by dividing the top and bottom by 45 and 45. If you take 45 divided by 45, you get 1. 180 divided by 45 is equal to 4. So it's our fraction 1 pi over 4. Or if you just want to write as pi over 4, that's probably a little bit better answer. To do conversions from radians to degrees, we're going to take pi over 3, for example. And the conversion factor here is multiplying by 180 over pi. So we're going to take pi over 3 times 180 over pi. This is the correct conversion because here our pi's will cancel. You get 180 divided by 3. You can divide that out, and that is equal to 60 degrees. What I'd like you to do is pause the video and see if you can come up with the degree measurements for 5 pi over 6 and negative 3 pi over 4. For 5 pi over 6, we multiply by 180 over pi. Pi is on the top and bottom will cancel. If you multiply the numerators together, you get 900. It's divided by 6, which equals 150 degrees. For the other example, negative 3 pi over 4, also being multiplied by 180 over pi. Pi's cancel. Multiply the numerators, you get negative 540. The denominator is 4. When you divide these, you get negative 135 degrees. What we're going to do next is we're going to find radian measures on the unit circle. Now we've talked about these degree measurements here. We've also talked about coordinates as well. Let's sketch out what the radian measurements around the unit circle are going to look like. Now, just like we have 0 degrees, this value here on the right side of the x-axis is measured as 0 radians. And if you go in the counterclockwise direction, that's considered to be a positive angle. If you go in the clockwise direction, that's considered to be a negative angle. Now we know that all around the circle is 2 pi radians. So I'm going to put, not only is this 0, but it's also 2 pi, similar in degrees to being 0 and 360. So if all the way around the circle is 2 pi, halfway around the circle is equal to pi, which we alluded to earlier, there being about 3.14 radians around the unit circle. You can see how we fit just over 3 and a little bit more around the unit circle. It's actually equal to pi. So if halfway around the circle is pi, if we go half of that distance, this value up here would have to be pi over 2. Halfway to pi radians. So this is like halfway, 1 pi. This would be 1.5 pi, or 3 pi over 2, and then 2 pi. So if you're counting by pi units, again, pi over 2, pi. 3 pi over 2, that's like 1.5, 2. So we're counting by halves. Now, if we take half of this distance right here, half of a half is a quarter. This is a quarter of the way to here. If you think of this half circle as being pi, this is a quarter of the way to this distance right here. Our 45 degree measurement is pi over 4. It's like 1/4 of the way to pi. 1/4, 1/2, and then this measurement here is another 3/4 of the way. So if you're going by quarter measurements, we have 1/4 of the way, halfway, 3/4, 1. Now if you keep counting by 1/4, 1/4, this is like 2/4, 3/4, 4/4, which is pi. Here would be 5/4, 5 pi over 4. This is like 6 pi over 4, 3 pi over 2. 7 pi over 4. And then 8 pi over 4, which would equal 2 pi. Now what we also have these other measurements. I'm going to use a little different color here to talk about these measurements. Pi is here. Now, if you imagine looking at this piece right here, and we'll kind of even shade it in so you can see it. There are lots of pieces that are this size around the circle. We have this one. Here's kind of our next one. I'll shade an alternate one so you can kind of see what I'm talking about. Here's our third one. Here's our fourth one going right through here. Here's our fifth one right here. Here's our sixth one right here. It's like there'd be like 6 pieces of cake here. This splits the unit circle into sixths. So if half of the circle is equal to pi, this would be 1/6 of the way. We'll call it pi over 6. The next point is 2/6. Now instead of writing as 2/6, 2/6 reduces to 1/3. We're going to call that pi over 3, 1/3 of the way to pi. 1/6, 2/6, this is 3/6, like the same as 1/2. This is 4/6. 4 over 6 is equal to 2 pi over 3, or 2/3. So we have 1/6, 2/6, 3/6, 4/6, and 5/6 right here. So we're just counting by sixths around the unit circle. Here's where 6 over 6 would be. 6 over 6 is like 1 pi. Now if you continue going around the unit circle with these same measurements, these same fractions of 6, 1, 2, 3, 4, 5, 6 over 6. Our next marking would be 7 over 6. We write as 7 pi over 6. 8 pi over 6, which is the same as 4 pi over 3. 9 pi over 6, which is 3 pi over 2. 10 pi over 6, which is the same thing as 5 pi over 3. And 11 pi over 6, which is this value. And what you'll notice, similar to how we set up problems dealing with coordinates, you'll notice that anything that has a denominator of 3 is directly across from each other or vertically up and down from each other. We'll draw the little rectangle here. You'll notice that each of these fractions has a denominator of 3 that make this rectangle. And you'll notice a similar observation if we're working with the 5 pi over 6 values, where all of these values across from each other have a denominator of 6, or any of the values that have a denominator of 4. So to solve problems like sine of pi over 6, what we're going to do is we're going to identify where our angle is located at. We can see pi over 6 is here. It's sort of the same location as our 30-degree measurement was. You may recall that if we're dealing with sine, sine is the y-coordinate. Kind of has that same sound to it. So we're looking for the y-coordinate at pi over 6 right here. Now some of you might be able to kind of estimate it based on about how high up this is here. If necessary, you can refer to our information from our 13.2 notes worksheet that talked about the y-coordinate here at this angle. And you can see the y-coordinate is up 1/2. It's basically halfway up the y-axis. So the y-coordinate we're going to write down is just being 1/2. What I'd like you to do on the rest of the problems is I'd like you to figure out what the sine and cosine values are for each of these angles around the unit circle. Remember, sine is referring to the y-coordinate at this value. Cosine is referring to the x-coordinate at this value. We'll pause the video and see what you came up with in just a moment. For finding the sine of 5 pi over 3, we're looking at this angle that's down here in the bottom right corner. Sine is the y-coordinate here. So if we refer back to our original data here, the y-coordinate at 5 pi over 3 is equal to negative root 3 over 2. It's this number that's sort of in red right here. It's the y-coordinate at this value. To find the cosine of 3 pi over 2, we're looking for the x-coordinate at 3 pi over 2. 3 pi over 2 is down here at the very bottom. The x-coordinate here is 0 because that's the point 0 comma negative 1. The x-coordinate is 0, so that's what we write down for that value, as you can see here. Finally, for cosine of negative pi over 4, pi over 4 is located basically at 45 degrees. So if we were to go to negative pi over 4, not pictured, we would be going in the clockwise direction, this direction, the same distance. So here's where pi over 4 is. Negative pi over 4 would be that same distance but going in a clockwise direction. So it's coterminal with 7 pi over 4. The x-coordinate, because we're dealing with cosine at this value, is equal to square root of 2 over 2. That's this value right here in green. Finally, the last thing we're going to do today is find the length of an arc on a circle. There's a simple formula to find the length of arc. The letter S is a strange abbreviation that actually refers to the length of the arc. R represents the radius of the circle, and theta represents the angle you're working with in radians. So you're not allowed to use degrees in this formula. You have to convert degree measurements to radians. To find the length of arc in this first circle, which they're calling S, what we need to do is take the radius times the angle in radians. In this problem, r is clearly equal to 6, and the radian measurement, it is in radians because you can see 2 pi over 3 is 2 pi over 3. 6 is like the number 6 over 1, so when you multiply this out, you would get 12 pi over 3. This is obviously equal to 4 pi. So the question is, what do you do if you have an angle that's listed in degrees? Well, if it's in degrees, convert it to radians. Here we also have an angle that's in radian measurement, so to calculate S, again, we take r times theta. The radius of this circle is 3. Our angle is pi over 3. If you cancel out the 3's, you just get pi, and that is the length of this arc right here. And that's simply how you find the length of arc on a circle.